Question 6 again. Go check out the playlist for all the other questions. This is November 25, paper 2, HLSL. It'd be exactly the same paper for both. We finished questions 1, 2, 4, and I just skipped over 5 and skipped over 6 as well and went to 7. But now we're coming back to 6. So let's get through this one. So let's first look at the questions. SLS, so that is selective laser sintering, which is a 3D printing method, right? 3D printing. So they're saying, why was it used for this bracelet that we see here? Next one was designed using dematerialization principles. Explain why dematerialization was an important consideration. Okay, now do we know what dematerialization is? I think it was in the next question as well. Let's see, dematerialization. Yes, it was here as well. So they asked they ask about similar concepts, but sort of change up the question. So dematerialization is the reduction. In fact, let's put our definition here. So even without looking at the case study, we can get some points, right? So dematerialization. Okay. What's our definition? The reduction of total energy and material, right? Throughput, which means inputted into the production process. And material throughput, total, oh, I forgot total, but so total energy and material throughput for any product or service. Oops, or Wi-Fi connectivity, or any product or service. Okay, that's perfect. Now, let's go back. Let's look at the question and the case studies. Okay, what else? Two drivers for invention. So we know our drivers, we have desire for money, right? To make money, to make money. I think we have 5 main ones, right? That's in the syllabus. Desire to help others. We have constructive discontent, which is, we can go deeper into that, right? Once we read the case study. Content, we have, what's the other one? This is when you see a problem and you see an existing solution that is terrible and doesn't sort of solve the problem effectively. And so you're annoyed, you're dissatisfied, that's the keyword, and you want to build a better solution. And next is technical or scientific curiosity, right? Or discovery, right? So something like, we can say Thomas Edison, or uh, when you invent something out of scientific curiosity and not necessarily to make an existing solution better or to help others or to make money, but just because you you're motivated by maybe learning and building. Okay, so those are the main ones, and then you obviously have personal interest, right? Personal interest, and that sort of combines with personal interests or motivations to express creativity. right? So in the TT syllabus, these are the main ones. So yes, these are our five main suggest two drivers for invention. Okay, so essentially choose one of these two and then build your argument, right, around that. And then we have a 9 marker. This is pretty straightforward, right? Explain why some designers do not protect their IP with patents, trademarks, copyright. So first we have to define what each of them is, and then explain the disadvantages, right? So we can come to that later. Let's get started with the case study. Bond Touch bracelets are a new product range that use haptic technology, right, to communicate with loved ones who live at a distance. So loved ones who live at a distance. Bracelets. They use web-based technology worn on the wrist and it works by users touching the bracelet's module. Okay. Digital vibration. Receiver feels the digital vibration on the wrist no matter how far apart they are. This touch feedback is designed to mimic the subtle nuances of a gentle touch, providing a comforting, okay, and reassuring sensation, making them feel closer to each other. Uh, Not exactly related to the questions. So, Bond Touch bracelet designers wanted to trial the bracelet before use and therefore produce prototypes using. Okay, so this is part of our question. We can say it's an additive process, right? It's 3D printing. It's just a different type of 3D printing. So additive, it is low cost since it's for prototyping, right? Low cost, rapid prototyping, right? Now you can't use FDM or something like this. So you would maybe say, right, this would need supports and so no supports needed or minimal because it's essentially a laser that hits this bed of powder that's heated, and so it essentially, let's say, sinters means uh, burns, burns and combines these powders into creating a solid uh, material, right, product. And so it should actually be zero supports. So no support needed. And it's typically used for bespoke, which means one-off, and sort of high quality, high personalization. And since this is a one-off product, right? So bespoke one-off, it's a prototype, right? So and it's very customized. There's nothing that looks specifically like this, right? They're building a new product. So bespoke one-off prototype that needs to be, let's say, has complex geometry, complex, high quality, right? And so we can mention any of those. And last thing to mention is the idea that it has a short lead time or runtime. Because it's for rapid prototyping, you can quickly build this prototype and sh- you can say for short runs, which means only one or two, three uh, bespoke sort of prototypes, right? So this is sort of linked to this. Short run, not mass. You wouldn't use SLS for mass production unless you had to do something like mass customization or you didn't or it's the most efficient way of producing your product, then you would use it. But this looks like you could use injection molding or something of the sort. Okay, so we already have some key ideas for that. Copyright, trademark patents are important for new product designs, however, overly confident. that their design is unique. This whole area can be confusing, complex, and can take a large amount of time. So maybe these are some disadvantages we want to be talking about for that question. Okay, then we have this diagram. Outline why SLS was used for the Bond Touch bracelet. Okay, first let's define SLS. SLS. Okay, no need the arrow. Okay, that's perfect. So SLS, we already mentioned, is an additive manufacturing technique, right? This is all from the AT glossary of terms and mark scheme. So an additive manufacturing technique, this is our definition. And always remember the long form, so selective laser sintering. So laser, so that uses a laser to sinter or fuse. Sinter means burn and fuse them together, right? When you provide energy, uh, particles can fuse. So that uses a laser to fuse. Actually, let's bring the laser down as well. That's a key point. That uses, oops, a laser to fuse particles in a heated bed, small particles of powder, right? Of powder in a heated bed of liquid, of powder in a heated bed. Okay. So that's our definition. Then we have to give our advantage, right? They're saying why was it used? That means we have to give an advantage for using SLS over something else. And the key reason they mentioned is uh wanted to trial the bracelet before use and therefore produce these prototypes. So it's for prototyping and trialing, right? So we can say ideal for all these things that we mentioned up here. Let's just write all of them, right? We don't know what sticks, so low cost rapid prototyping, no support needed, bespoke high quality product, short runs, right? For low cost rapid prototyping, uh, bespoke or one-off complex designs. What else did we mention? We mentioned no support required. In fact, let's make that a separate point. No support required, right? This is something you should remember about SLS. Now, FDM, which is our traditional 3D printing that needs supports, right? If something is sort of elevated in the air, or we have what we call overhangs, right? So we have a product like, let's say this is our product. Uh, so you have something like this, right? We are going to need some supports here and here, probably here as well, right? Just to keep it up. And because you can't print in mid-air, right? So this is called an overhang. Okay, let me maybe delete this. Hopefully that made sense. And let's see, what else did we mention? We mentioned short runtime, and yeah, that's essentially it. No support required and short runtime, right? So these are some advantages. Short, sorry, not short runtime, short runs, which means small number produced. Okay, and so we have our definition, right? In fact, let me highlight that. Definition, and that it's an additive process. This is also part of our definition, so both points are needed, right? So when you have something about 3D printing, additive, and then you have to define what that specific 3D printing does. Laser to fuse small particles of powder. And then it's ideal for low cost, rapid prototyping, one off complex designs, no support, and short runs. So these are our advantages. Next is the application to the case study. Why did they want to use it for that bracelet? For trialability, right? Trialability. Uh, they said before and after use, right? Before, before and after something. Before use and okay, so just before use. Before use, uh, and prototyping. So this is the application to the case study, and you'll get one more for that. So this is application. And so these three, oops, are just advantages, right? So that's times 1, you would get one more. This is times 1, and this is times 1. So that's our allocation. Okay, on to the next question. Part B was designed using dematerialization principles. Explain why dematerialization was an important consideration of the design. Okay, so we have our definition, reduction of total energy and material throughput for any product or service. And that gives you 1 mark already. And again, the importance of this, and we covered it in question 7, so go check that out in the video. Importance of dematerialization is it's a sustainability strategy, right? We're reducing energy and material, so we're reducing waste. We're reducing the amount of raw virgin material that has to be extracted from the earth. Uh, and that extraction from the earth requires a lot more energy. And so we're being more sustainable, reducing our environmental impact. And we have lower end of life sort of waste, right? Because there's less material. So let's see what they mention. If we need to connect it to the case study, if there's nothing there, then maybe there's no connection to the case study. So I don't remember there being much. So there wasn't. Yes, there's not much about dematerialization. So this is our general sort of answer to any question about dematerialization. You have to remember these key points. Reduction in total energy and material as less, or which means so less, okay, something less material uh required, right? And this is the exact same as question 7. So less material required, which means uh, less uh extraction of raw, we can say less extraction and consumption, right? Consumption of raw virgin materials. Of raw virgin materials. We can also do the energy argument, right? Both are valid, but again, depends on the question. Here they haven't mentioned, so you can use the energy argument. In question 7, they specifically mentioned reduced materials, so you have to only talk about material. Uh, or so less energy required in production, and so that just means less energy consumption, right? Less energy consumption. Okay, that's one possible mark. So if we're using less energy, we're probably having less pollution, less emissions, less heat dissipation, which is waste. And if we're using less material, we're also reducing our waste, emissions, and pollution. So less uh, waste produced at end of life, right? Less waste, uh, pollution, emissions. So any of these are valid or lower environmental impact, right? We can add that at the end. That's always the additional point we want to make, even if it might not be on the mark scheme. So less waste, pollution, or emissions in production, which means and in production and end of life, lower uh, end of life uh, disposal, lower waste during end of life disposal. Waste during end of life disposal. And that is since the product has less material anyway. So if you put in the landfill, it's occupying, less space, less is polluting the environment. So lower environmental impact. Okay, so those are our key ideas, and we could get those 3 marks just from uh this is our key definition. So you need that. Then you need one of these two, right? So let me put this or then we need this. So you just need 3, right? And then you could mention either of these. So let's say or for these two as well, right? Perfect. But I would mention all of them. No point only mentioning 1 or 2. Okay, we can move on to this in the next video. This will be a long one, so let's cover that in a separate video. Hopefully this helped, guys. Yeah, we're just making our notes and going through, and you can highlight, so do take a screenshot, but I do encourage you to instead write these notes down yourself and it becomes muscle memory, right? uh Otherwise, good luck, and do drop a like and subscribe if this helped. See you in the next one.